Sir Isaac Newton, the man who made calculus, discovered gravity, several laws of physics, and made the reflecting telescope. Newton was born January 4th, 1643 in Lincolnshire, England, and died March 31st, 1727. At the age of 12 through 17, Newton went to a school that only taught Latin and Greek with no mathematics. And he was then pulled out of school to become a farmer. But then Newton hated farming, so his mother sent him back to school for basic education. Newton then graduated and moved on to Cambridge College, where he became interested in advanced science. Newton then spent most of his free time reading about modern physics and kept an extra set of notes about his understanding of the science world. Newton eventually graduated from Cambridge and also came back to become a professor there. Newton wrote books and shared information that he discovered of his understanding of physics in the science community outside of his job. One piece of Newton's work is known as his second law of physics. Newton's second law states that acceleration is equal to mass times net force. If the mass of an object were to increase, then the acceleration would decrease. But, for example, it would be really simple for a person to push a pencil over with a small amount of force. But it would be really difficult for a person to use the same amount of force to something quite larger. You would need a large amount of force to push an object that has a large mass. Another piece of Newton's work is known as his third law of physics. His third law can be described as every action has an equal opposite reaction. The image shows a person pushing back on a skateboard to move it forward. The action is pushing backward and the reaction is moving forward from the force. Let's say if this character named Bob were to run into a wall. As soon as he touches the wall would push back at him with the same amount of force used. This would cause our character Bob to either fall back or have a not nice injury. But how come if the forces are equal and they're in opposite directions, why don't they cancel each other out? In this image, two people are pushing against one object with the same amount of force used. The net force would be equal to 0, therefore causing force cancellation. In this image, it shows two objects at rest. None of the objects are accelerating, but they are pushing against each other.